We have finally made it to the end of Module 7, where we're looking at Lesson 6, Write and Solve Two-Step Inequalities. And quite honestly, this is the only lesson in the entire module that I think is even remotely challenging. So let's take a look at it real quick. It says it's only going to take us 45 minutes. That's a single-day class. I think this one could possibly take a little longer, but we shall see how it ends up going. We've got a total of 15 resources to work through, starting with this one. On Mackinac Island in Michigan, a ban on motorized vehicles has been in place since 1898. The island is a popular tourist location in Lake Huron. People travel around the island by foot, on bike, and by horse only. That's it. That's the only ways you can move around that island. The distance around the island is about 8 miles. On a vacation, the Gonzalez family would like to rent bikes for the day. Suppose the Gonzalez family would like to rent 2 bikes to ride around the island. There is a daily fee of $25 for the 2 bikes altogether, plus $4 per hour per bike. The Gonzalez family would like to spend no more than $75 for the day. Without writing an inequality, how can you determine the number of hours for which they can rent the bikes? Well, these are some of the things we're going to talk about in today's lesson. We're going to dig in with a new vocabulary term. A two-step inequality is an inequality that contains 2 operations. And by 2 operations, they mean like maybe multiply and addition, division and subtraction, division and addition, something of that nature. Multiplication and division, that is not a two-step because those are just opposites of the same thing. Let's take a look at a video that the textbook has on how to do these.
A two-step inequality contains 2 operations. To solve a two-step inequality, first undo the addition or subtraction. In this example, undo the addition by subtracting 6 from each side of the inequality. Next, undo the multiplication or division. In this example, undo the multiplication by dividing each side of the inequality by -2. If you multiply or divide each side by a negative number, remember to reverse the inequality symbol. The solution of the inequality is x is less than or equal to -3. Finally, check the solution. Start with the original inequality. Replace the variable with the number in the solution set. Then simplify to check whether the sentence is true. If so, this provides evidence that the solution is correct.
All right, a couple of things I want to point out here. One is that she said it provides evidence that the solution is correct. It's not a guarantee the solution is correct, because you could come up with a number here which would give you a true statement here that is not actually going to be the correct answer. I also want to go back to where they were right about here. Let's see, where's that one at? Here, and talk about what they did. They undid addition and subtraction first, subtracting 6 on both sides. That left them with -2x is greater than or equal to 6. Then they undid multiplication and division. We work these just like we work in any equation. The only difference occurred right here. When they divided both sides by the -2, the sign changed directions. Other than that, this is identical to the equations we worked in the past. The textbook has given us an inequality here to work. -5x minus 12 is less than or equal to 8. And we're going to start off by doing exactly what they said. We're going to undo addition and subtraction first. So they wrote the inequality. Remember, if you don't write your original problem, I'm not giving you credit for it. You're going to write the inequality. After writing the inequality, next thing we're going to do is say, well, what's being added or subtracted from x? This 12 right here is. It's -12, so we're going to take and add 12 on both sides. The 12s here on the left are going to take and zero each other out, leaving a -5x, which is going to come down over here, and then 8 plus 12, that gave me the 20 right here. Next, we're going to undo multiplication and division. -5 is being multiplied by x. We're going to undo times the -5 by dividing, I said by dividing -5 on both sides. Now I want to point out when I did this, look at the sign right here. The sign changed directions. The reason the sign changed directions was because I divided both sides by a negative number. The only time you change that sign is if you multiply or divide both sides by a negative number. On the left-hand side, these negative 5s, they're going to divide each other out, becoming 1. 1 times x is x. The greater than or equal to comes down. 20 divided by negative 5 is negative 4. So your final answer is going to be x is greater than or equal to negative 4. Check it. Easy math. Now that is how you work the problem, but they also want you to talk about checking it. So to check it, where they had the x right here, they're going to substitute in that negative 3. Negative 5 times negative 3, that's going to become a positive 15. Positive 15 minus 12, that's going to end up becoming a positive 3. Is positive 3 less than or equal to 8? It is, so that provides evidence that our answer is probably right. Now the next thing we're going to do is graph our inequality. Our answer was x is greater than or equal to negative 4. So we're going to take, and it's an or equal to, that means we get the solid circle. We're going to start at the negative 4, and we're going to go to the side that's greater than it, just like that. Check our answer. The answer checks. So the graph of your inequality, start at the negative 4 and go to the right throughout all time and eternity. Easy math. Now it's going to be your turn. Work extra example 1. Check your answers. Alright, to solve this problem, I'm going to undo addition and subtraction first. That means the first thing I need to do is I need to take and get rid of this minus 2 that I have going here, because the 2 is what is subtracting itself from the x. So I'm going to get rid of that by taking and adding 2 to both sides. When I do that, these are going to zero out, leaving 7x. My sign stays the same. And then negative 16 plus 2, signs are different. Find the difference, which is 14, and the sign from the larger number goes in front of the answer. Next, we're going to undo multiplication and division. 7 is multiplying itself times x, so I'm going to divide both sides by 7. Now the sign is not going to change direction because I divided both sides by positive 7. Yes, I know, there's a negative 14 there. I don't care, because I didn't do anything to that. I divided both sides by negative 7. I did not divide both sides by negative 14. The sign stays the same. These 7s divide by positive 7. These 7s divide out, leaving x. Over here, 14 divided by 7 is 2. Negative divided by positive is a negative. X is greater than or equal to negative 2 will be our answer. Jump back to our answer page. Greater than or equal to negative 2, and the answer checks. Now we're going to graph it. It's an or equal to problem, which means we need a solid circle. I'm going to start at negative 2. X was greater than it, so we're going to start here and go to the greater than side, which is right there. Check that answer. It checks too. Easy math. Anybody can do this stuff. Example number 2 involves the same type of problem, only this time they're using rational numbers in the form of decimals. Other than that, it's going to work just like everything else we've done. So you're going to take the problem, you're going to write your inequality first. After you write your inequality, what are you going to do? You're going to undo addition and subtraction. Where they had minus 3 and 2500ths, we're adding 3 and 2500ths to both sides. 3 and 2500ths on the left zeroed each other out right here, leaving 4.7x, which you see came down here. The less than or equal to sign came straight down, and on this side we're going to take and add it up. That's going to give me 14.1, I believe. Did I do that right in my head? Check. And it checks, so we got a 14.1 when we added these two up. It could have also done 14.10, but why bother writing that 0? Next, we're going to undo multiplication and division by dividing the 14.7 on both, the 4.7 on both sides. That's going to take place right here, and you can see the sign did not change direction. I did not divide by a negative number. It did not change directions. These 4.7s, they're going to take and divide each other out. And then right here, 14.1 divided by 4.7. Well, that we're going to have some scratch work on. So I'm going to take and set it up. 14.1 divided by 4.7. I'm going to bounce my decimal until I hit the wall. Bounce this decimal the same number of spaces to the right and move it up. Then I'm going to say, well, 47 goes into 141. That's going to be 2 times, which is going to give me a 14, an 8, and a 9. Nope, I'm thinking it's actually going to be 3 times. I think they gave us a nice number to work with. So we're going to do 3 times 7 is 21. 3 times 4, that's going to be 12, plus 2 is 14. And when you look at that, we have nothing left over. So we're going to jump back over here, put our 3 in, and check our answer. The answer checks. Now they also did want us to graph it, I do believe. So we'll go back here to graph our solution. X is less than or equal to 3. Since it's an or equal to, we're going to have a solid circle starting at the positive 3. And this time we're going to the less than side, which looks just like that. Check your answer, and the answer checks. Easy math. Now, once again, it's going to be your turn to solve a problem on your own. Decimal problem, just kind of like what we just did there. After you solve it, you also need to graph it. Make sure you can do it right. Get started. All right, it's my turn. Going to start off by undoing addition and subtraction. For this one, 5.6 is adding itself to x. We're going to make that go away by subtracting 5.6 on both sides. Whoops, wrote the wrong number there. 5.60 on the right. These are going to zero each other out, leave me a negative 3 and 62 hundredths. X is less than. Over here, we're going to have signs are the same. Find the sum. So that's going to become a 5. That's going to become a 10, 11 decimal. And then we're going to have an 8, 9. So we're going to, and that sign from a larger number goes in front of the answer, giving us negative 9.15. From here, we need to take and isolate the variable. Isolating our variable, we're going to divide both sides by the negative 3.62. Divide by negative 3.62. This one's not going to divide out as pretty as the last one did. These divide out becoming 1. 1 times x is x. And because I divided both sides by negative, my sign changed directions. Now I'm going to come off to the side to do some grunt work. 9.15 divided by 3.62. Now I just went back and checked my math before I got into my long division. Always a good idea to check your math before you get into long division. And I found out I did have a boo-boo here. That should be a 0, and that should be a 0. Now that I got my boo-boos fixed, I can take and dive into my problem. Bounce my decimal 1, 2 spaces to the right. Do the same thing inside the house. And when I do that, I'm going to say, well, how many times is 362 going to 905? That's going to be twice. 3 times would be too many. 3 times 2 is 4. 3 times 6 is 12. 3 times 3 is 6, plus 1 is 7. And when we subtract that, I'm going to have a 1. We're going to do some borrowing here. 10 minus 2 is 8. And 8 minus 7 is 1 for 181. I'm going to take and annex in a 0 and bring it down. Of course, the decimal went up there. And then I'm going to say, well, how many times is 362 going to go into 1810? That's pretty tough. And I'm going to take a look and say, if I did 3 into 18, that would be 6 times. But I don't think it's going to be 6 because 362, that's kind of closer to 400. So let's try 5 instead. So I'm going to do 5 times 2 is 10. 5 times 6, that's going to end up being 30, plus 1 is 31. 5 times 3 is 15, plus a 3 from the 31 is 18, with nothing left over. So my answer is going to be x is greater than 2.5. Jumping back over to our textbook page, we're going to have x is greater than actually that's going to be, hold on, let me make sure I got my signs right here, because I had a negative divided by a negative, so yes, it is going to be a positive 2.5. So I'm going to put 2.5 in here, check my answer, and the answer checks. Next thing we're going to do is graph it. So we're going to say it's not an or equal to, so it's an open circle starting at 2.5 and x was greater than it, so the arrow is going to go to the greater side. Check your answer. The answer checks again. This is where we're going to end part 1 of this lesson. Come back in just a little bit and check out part 2, where we're going to continue working on learning about how to work these two-step inequalities.